All right, this video will be about pitch, centricity, and symmetry. In particular, we're going to look at the music of Bartok when we talk about this. So the first thing that we're going to talk about are interval cycles. You can see different intervals kind of mapped out here as though it's almost like the face of a clock. So this first one that is showing on the top left is showing you what it would look like if we were doing just semitone intervals. Okay. Now all of these are going to show like symmetrical divisions of the octave eventually. So this first one, if you think back to the scales video, if we had a scale that's only semitones, probably learned this a long time ago, it's a chromatic scale. Okay, so every single note is separated by just one semitone. Sounds like this. All right, the second one should be familiar from the scales video. So if you look at this one, now we're going a note 2 semitones away. Okay, so we're going 2 semitones, and then this would also be 2 semitones away, 2 semitones. Or in other words, they're all whole tones, right? So a whole tone scale. There will be a picture on the next slide, and I'll play that one. So the next one is showing us a cycle of minor thirds, basically. Okay, so all of these are just thirds apart, okay, which you would probably know better as just a fully diminished chord, right? So if it's all minor thirds, right, and then if you kept going up by minor thirds, then you end up back where you started, right? So if we start here and we go around minor third, minor third, minor third, and then we're right back to where we started. Okay, so this one then starts on a new one. So we can go around, we can start on like 3 different notes, right? So here's number 2, but once we get back to 3, then if you look at how 3 works, see we're back at 0. So there's only 3 like rotations, okay? For this first scale, there's only 1 chromatic scale. For the whole tone scale, there are 2, right? So we can start on 0 or we can start on 1, okay? For minor thirds, there are only 3 different possibilities. We can start on 0, 1, or 2. But then if we start on 3, it just repeats what we had for 0. Okay, so this cycle 4 is showing us if we had 4 semitones. So in other words, major thirds, okay? So if we went from here, we have up a major third, and then we would be right back to where we started. Sounds like this. Okay, so it's an augmented triad, in other words. Okay, so you can see on this one, we can start on 0, we can start on 1, and end up with different notes. Okay, we can start on 2, end up with different notes / numbers. We can also start on 3, but once we get to number 4, then we're just repeating. Okay, so there are 4 different possibilities for that cycle. Okay. These next ones, if you're looking at like this one, okay, so cycle 6, that means that we're doing tritones. Okay, so once you do a tritone from here, from like C, for instance, and go up to F sharp, if you keep doing tritones, you get right back to C, right? So you can't really do like a scale potentially with it, right? But we can use it for other things. This one down here is if you were doing circle of fifths, basically. Okay, so like if you went up a fifth or down a fourth, either one. Okay, so this last one is just showing you basically the circle of fifths. Okay. Okay, so now you can see them like visually. Okay, so all of these split the octave equally. Okay, so the first one I already played. It was just that chromatic scale. So the whole tone scale, if you start on C or on note 0 is what we usually call that one if you're using an integer. So the first option is this. Okay, and if we keep doing whole tones, right, so 2 semitones, then we end up back on C, so we can complete that one. If you start on just a semitone higher, so on D flat, then we'll have the same thing. Okay, so okay, if we started on D, so if we kept going up a semitone, then it would just be the same scale as this one. Okay, same notes. Okay, so this one, the third cycle on there was all minor thirds. Okay, so this one could have also have been written as like a B double flat, for instance, but A is easier to read. So all of these are just going to sound like fully diminished 7 chords. Right. The second one on here starting on C sharp, and then the third one. Okay, so all of those are just minor thirds, and there are only 3 different possibilities. Okay, the fourth one is dividing it in like groups of semitones that are 4, so major thirds. Okay, so we talked about how these all are going to sound like augmented triads, basically. So here's the first one. Okay, second one, all major thirds again. And then the third one. And the last one. Okay. All right, the last one is divisions of the octave using tritones. Okay, so we're like really splitting the octave exactly in half if you're using a tritone. So it just sounds like this. Okay, so there's one possibility, second possibility, and then third possibility, fourth possibility, fifth possibility, and then sixth possibility. If we kept going, we'd be back to F sharp, which is in that first one. So it would just repeat. So there are 6 possibilities for that one. Okay, so the reason that we talk about these interval cycles is because we see like groupings of these as little cells in Bartok's music. Okay, so we're going to label these cells like we're doing math, so with X, Y, and Z. Okay, so cell X is really just a segment of a chromatic scale. Okay, all of these are just 4-note cells, basically. Okay, and they could start on any note, really. Okay, it doesn't have to start with a C each time. Okay, they can be transposed so that they can start on other notes. Okay, but as you can see, cell X is just a chromatic scale. Okay, so we're just using 4 pitches that are all separated by a semitone. So, okay, you could start it anywhere though. So cell Y is a group of 4 notes that are part of a whole tone scale. Okay, now cell Z is actually going to be like 2 overlapping tritones. So part of that interval cycle 6. Okay, so if you look from the first to the third note, so C to F sharp, and then the C sharp to G, so second to fourth notes. Okay, those are both tritones, but in order. Okay, they can be in other orders too, so you can see it over here. This one isn't so obvious about the tritone because it actually uses like 4th intervals, right? So, okay. But if I played the first note to the third note and the second to fourth note, you can hear the tritone now. Okay, the tritone it pops up all the time in Bartok's music. Okay, so we can see these cells used both melodically and harmonically in Bartok's music. So I'll show you some examples. So the first one is basically melodic in its use. So you can see that first one is going to be divided up between the violin parts. Anyway, okay, so we have. Okay, so if they were all in the same octave, that's a little bit more obvious, I think. Okay, if you look at just the violin 1 part, it'll probably sound a little bit more obvious, but he's not using the cell like in order, so it's not necessarily like a chromatic scale that's in order. So violin 1, so starting on that high F. Okay, so those are both from cell X because that's all semitones. Okay, or in other words, segments of like a chromatic scale. Okay, so you can see in this one that the cells are actually being used harmonically instead. Okay, so in the first example, we see the cell X, so remember that one's basically the chromatic scale, okay? So we have all notes that are separated by just semitones, basically. Okay, so we've got, let's see, I have to remember how to read in tenor clef, but that's a C, and then a C sharp, a D, and a D sharp, okay? So it would sound like da, da, right? So they wouldn't all sound at the same time, like when they are first sounding, but eventually, yeah, you would hear all of those notes together because they're all holding, so, right? If you look at what's happening in just this violin one part up here, we have another cell X up here because we have F sharp, B sharp, D sharp, and E natural. So I was trying to hold all of them so that you could hear that they're all just semitones apart. Okay, then right here, cell Y is what we could also refer to as the whole tone scale, right? So we have, this is actually a B flat, okay, and then a C, and then a D, and then an E. So all together, okay, it's a whole tone cluster, basically, okay. Then same thing right here, it's another whole tone cluster, and then he's still using X's as melodic and harmonic, okay, so you can see them. Sometimes they don't happen all at the same time, but they're holding at the same time, so basically harmonic. It's liking to use that Y as a harmonic use. Okay, more examples, just in case you weren't convinced already. Now he's doubling up some of the notes, right? So now we still have, like for instance, on this Y, it's still just the whole tone cluster, but now there's more notes, so more doublings, and I can't play that as one person on the piano, so you can imagine it, and we'll listen to it later, the whole thing. Okay, now cell Z, okay, so Z is the one that has that overlapping tritones, okay, so two tritones, which can also look like fourth intervals separated by a semitone if you arranges it in a different order, okay? So in this one, it looks more like the fourth interval, so it looks like fourth right here, and then we have a fourth right there, and they're just separated by a semitone, okay? But if you look every other note, so D to A flat and G to D flat, those are our tritones, okay? So here's what it sounds like. Okay, so every other note, right, tritones. And then at the same time, he's also using the cell Y, which was a whole tone fragment, as like harmony, basically, for this tritone thing that's happening. Okay. Okay, then we see it again here. So this is a bunch of the same cell. Okay, I won't tell you what it is first because I'm going to play parts of it and then you can figure out what you think is happening. Okay. Okay, so the top part is doing this at first, and then the other part down in the bass clef is doing, and it does, and then, anyway, so on and so forth. Okay, so take a minute to figure out what cell you think is happening. All right, if you think it's cell Z, you are correct. Okay, so cell Z is the one that has tritones, or what look like fourths sometimes too. It just depends on what order he kind of puts the notes in. Okay, so he's doing the same like fourth intervals separated by semitone. So fourth, and then semitone, and then another fourth. Okay, and then he does the same thing in the left hand, but basically inverted. Right? So on this one, we start on E and we go down with the cell. On this one, he starts on E and then he goes up. And then he repeats it right here, but just the first three notes. So he takes these first three, doesn't have the fourth one in, because then he kind of interrupts it. And the same thing that appeared over here goes up an octave. So it's kind of flipped, mirrored images of each other, basically. Okay. Okay. Next. Okay, next we're going to talk about symmetry around an axis, which also pops up quite often in Bartok, especially. Okay, okay, so if we look at this Bartok, it's a whole tone piece from the Microcosmos, which we actually saw in think I brought it in for the whole tone scale video too, but anyway, here's what it sounds like. Okay. This one's called whole tone scale because it's using the whole tone scale. Okay. So, or in other words, Bartok is using his cell Z very often, right? So if you look at what notes we have an E flat and a D flat. Okay, so if you think from like potentially D flat, we have D flat, E flat. We do have an F down here. We have a G right here and an A natural and a B. So if I played all those notes in order, and we'd be back to D flat. So it's just a whole tone scale. Okay. Okay, but if you look at how the notes are arranged, it's almost as though like this top part is kind of mirrored, right? It looks kind of like he's done that sort of effect, right? A mirroring kind of effect. So what's happening right here is these notes are symmetrical around a certain pitch, okay? So they're symmetrical around an axis is what we call it. So for there to be symmetry, the note that they're symmetrical around doesn't have to be there. It can be just like an imaginary axis, which is what's happening in this one. So if you look right here, so E flat, and A, okay. So then if you're looking at just E flat and E flat on the piano, so the note that's right in the middle of that would be this E flat right here that you see down below, right? If you look at A compared to A, like that, the note that is right in the middle is again that E flat. Okay. Same thing. If you keep going and you keep thinking, okay, like what note is exactly in the middle? It's E flat every single time. Okay. A way that you could figure that out on the piano, it's pretty easy because let's say, for instance, we took this A and A. If it's just an octave, it's always just going to be the tritone that's in the middle, right? Right. If you went from here, okay, so let's say you went from F to D flat, you could just play like semitones until you reach the middle. So anyway, and then you get to E flat basically every time. So for instance, let's take one that's closer together maybe. So B to G, okay. So up, or if you go like in a semitone, in a semitone, in a semitone again. Now they're just whole steps apart. So now we're on E flat if we keep going in on itself. So yeah, E flat was again the middle note exactly. Okay. So you could take any of these two notes and find out what exactly is in the very, very middle. Okay. Let's see. If you do like the other way, you can flip it around too. So if you look at this one right here, right? This one took those E flats, and this time, basically, we've like swapped voices, right? So all of them are inverted, okay? So we've got E flat up to E flat, and then A up to A. Those ones though didn't really change, right? But if you look at the next one, D flat and then F. So the D flat was in the right hand before, so it was the top note, and then F, okay, was the bottom note. So all of these are swapped, okay? So let's take like the one that we did before. So before we looked at B up to G, and the note that was right smack in the middle was that E flat, okay? So now in this one, we're going to have B down to G, okay? I'm gonna play them just close together though. Okay, so B down to G. So if you go in a semitone, so G would go up to G sharp, B would go down to A flat, right? And then in another semitone, you get to A, okay? And so any two notes are symmetrical around two axes, actually. So if you have them like in one direction, right? So B up to G, like it was in this one, then the note in the very middle was E flat, right? But if we invert it, so B down to G, then the note in the very middle is A. So the separation between those two axes, E flat up to A, are tritones apart. Okay, that's what will always happen, actually. Okay. So any two pitches are symmetrical around an axis, in particular two, and they're always going to be divided by a tritone apart. Okay, so it's called a double axis of symmetry. Okay. Okay, these axis of symmetry things can actually serve as tonal centers, and that's why we talk about it, because Bartok actually uses them as tonal centers in his music. So let me show you just a couple other examples of how you can figure out like the axis of symmetry. So I want to show you using this so that you can have a visualization, basically, like looking at a piano, how it's laid out. Okay, so here's the one that we just did, okay, but now you can actually see it, okay. So we've got a G right here and a B right here, right? So let me grab, okay. So we've got G and B, okay. Now if you think of how you would like kind of collapse in on itself to find the exact middle, so this one will go down and that one will go up, right? So A is right in the very middle, okay. So let's put in that A would be our middle note in that case, okay. But now if we went the opposite way, so if we had G going down to a B, so we're gonna go down to a B this time, okay. Then you could take like your two fingers, right? So here's G down to B, okay. And then we go in, so now we're on C, F sharp. Then you go in again, so C sharp, F. And then in again on itself, so D and E. And then in again on itself gives us an E flat, would be right in the middle, okay. Hopefully that makes sense now that you can see it on a keyboard too. So E flat was the one that was right in the middle. And remember, E flat and A are tritones apart, which will always happen when you have that double axis of symmetry. Your two notes, your two axes are going to be just a tritone apart. Okay, so on the next example, in case you need some more practice with this. Okay, so in our next one, we have C going up to G. So let's just mark those first. Okay, I think I have a stamp. Okay, so we have C up to G, okay. And then we're going to go like inwards, okay. So C is going to go up to C sharp, G is going to go down to F sharp as we figure this out, okay. Okay, here's what it sounds like. So here's C and G. Then if we're getting closer and closer to get to the middle, then we've got C sharp and F sharp. Then going in again, D and F, right? And then E flat, E, right? So the note that's in the middle isn't really clear right there. It could be E flat or E, since we don't deal with microtones, right? Okay, let's put that in. I still had my stamp on there. Whoops. Okay. Okay. I don't remember if that would let me do another E. Okay, let's try and put another E next to it. Nope. Okay, it won't let me. Anyway. Okay. Okay, and the next one, now we're going to do the opposite. So we're gonna have C going down to G next. Okay, C down to G. Okay, so if you can visualize that part, then go in on itself, and then in on itself again. So A, B flat is the axis of symmetry. So A and B flat are both the middle notes, okay. I think it's easiest to figure this out at the piano or like visualizing your piano in your head. You can also take like the interval and like split it in half, right? So do more math, okay? So for instance, in that first one, a major third, right? So we had a major third between G and B in the first example. So a major third is 4 semitones. If you divide it in half, you get 2, right? So that means that your axis of symmetry is just 2 semitones away from G or B, right? Either one. So if you take that other one, so B to a G, or G down to B, I guess, in other words, right? A minor 6, right? Which is, let's see, not 6, 7, 8, right? I think it's 8. Yeah, it's 8. So minor 6 is 8 semitones apart. So if you divide 8 in half, you get 4. So the axis of symmetry is going to be 4 semitones away from either the G or B. Okay, it's going to be like 4 semitones in the middle, or in other words, a major third. So in that one, it is a major third away from both notes. Okay. So multiple ways that you could potentially figure out that axis of symmetry, which can also function as tonal centers. So you can have 2 tonal centers at once. Okay. All right, that does it for this video. We'll practice more with Bartok in class.